Hi there, how are you? We are dealing today with complex rationals. I'm going to actually take two approaches to this problem here. I'm going to do them side by side, but I won't be doing them simultaneously side by side. I'm going to show you two different approaches. What you use is really up to you. I want to talk first about this one over here. I'm going to look at that denominator right there, and what I see in that denominator is I see two fractions that are being added. So what we need to do to add fractions is we need to get a common denominator. So this fraction will get multiplied by 1 in the form of x plus 4 over x plus 4. This fraction will get multiplied by x over x, which is also 1. So like I said, all I'm doing here is I'm simplifying this denominator. So I'll bring my numerator, 5 over x plus 4, divided by, 1 times x is x, over x times x plus 4, plus 2x plus 8, don't forget to distribute, over my common denominator of x plus 4. Now that we have a common denominator, you are allowed to add or subtract those numerators. So bringing down my denominator, 5 over x plus 4, divided by, let's combine the numerators, 3x plus 8, over x times x plus 4. Okay, that's looking pretty good right there. I see a fraction divided by a fraction. What you are most likely used to seeing is you are most likely used to seeing this in this form. Divided by you're used to seeing a division form most likely like that. When you see that, you should be thinking, oh, let's change the multiplication, so let's multiply by the reciprocal. So we can go right ahead and flip my second fraction and then change it now to a multiplication problem. Now, since it is multiplication of fractions, we can multiply straight across the top and straight across the bottom, which means it really does just become one big fraction like that. So we can cancel anything on the top for anything on the bottom. So I will take my x plus 4s away. 5 times x is 5x over 3x plus 8. There's the simplified version of that. Now I'm going to hop back up and I'm going to show you a different technique. So coming in here, we're looking at this complex fraction. You need to find a common denominator for each of my fractions, 1, 2, and 3. And each one of my fractions gets multiplied by the least common denominator. So the least common denominator of x plus 4, and x would be x times x plus 4. So each one of my fractions will get multiplied by that, and when I say that, I mean that over 1. Different than multiplying by 1 in the form of x plus 4 over x plus 4. So this fraction gets it. This fraction gets it. This fraction gets it. Now, each one of these fractions becomes a multiplication problem, and we're going to cancel. So I will take, don't forget that is my least common denominator, not part of this problem. So I will cancel the x plus 4 for the x plus 4. So now dealing with this, it is 5x over 1. Well, 5x over 1 is simply just 5x. That's my numerator. Coming in here, the x plus 4's cancel. X times 1, x over 1, simply x, bring down your plus sign. And then here we get, cancel the x's, so it is 2x plus 8. Now we can clean it up a little bit. And there we go. As you can see, if I were to slide down, you do have these same values there. Two different approaches. One, dealing with the denominator and adding those two fractions, and then multiplying by the reciprocal. So flipping this second fraction and multiplying by the reciprocal to get your simplified value. Or coming through and identifying a common denominator and multiplying each one of your three fractions by that common denominator to simplify down to that. So we will take a look at one more problem right here. (16 over x minus 2) divided by 4x plus 1 plus 6 over x. So now you need to identify a common denominator. I'll take the second approach that I did. You could add these two fractions together with a common denominator and then multiply by the reciprocal and do all your canceling. That is one way of doing it. Here I will identify a common denominator, least common denominator of x plus 1, x minus 2. So I'm going to multiply each one of these three fractions by that common denominator. X plus 1, x minus 2, x plus 1, x minus 2, x plus 1, x minus 2. So now each one of these three fractions is going to get multiplied by that. So first I will deal here, the x minus 2's cancel. So we are left with 16 times x squared plus x. Okay, well, we could have a factored form. There are multiple different representations we could have of this right here. Coming down here, x plus 1 and x plus 1. So that leaves me with 4x. This is just kind of a different form, different way of doing this, times x minus 2. We could have left this one as 16x times x plus 1. That may help us a little bit later. Okay, let's see, what else do we have here now? These. Okay, so it is 6 times x plus 1 times x minus 2. Okay, well, let's put together my x plus 1 and my x minus 2 as a multiplication problem. That would give us x squared minus x minus 2. And then that is just these two multiplied together. That will get then multiplied by 6. Okay, so if I do this, it is a plus an addition problem, and then I get 6x squared minus 6x minus 12. Okay, if we want to combine all these things together, we are definitely going to have to distribute there. So I am looking at, and I might as well factor the x out of this. When I factor an x out of this, it's going to go join the 16 there. So 16x, and you will be left with x plus 1. That's just an alternate form of this numerator. All over. When I distribute, I get, let's see, 4x squared minus 8x plus 6x squared minus 6x minus 12. Now we're just going to kind of bring everything together as much as possible, simplify, combine those like terms downstairs. 16x, x plus 1, over, let's see, 10x squared minus 14x minus 12. Okay, now it is going to be a factoring problem here. All right, my top's going to stay, but I need to factor my denominator, so I'm going to be factoring out a 2, 5x squared minus 7x minus 6. And my top, 16x, x plus 1. Okay, now we are looking to factor this to see if anything down here will cancel with anything up here, and we need to have that in a factored form. So my top, 16x, x plus 1, over 2, and this will factor to, let's see, we will have 5x and x, 3, 2, positives here, negatives here, and then we'll check it real quick. 5 times x is 5x squared for my front. The back is negative 6. Now we need to check this middle term with the outside and the inside. So 5x times 2, negative 10x, positive 3. So negative 10x and positive 3x does give me that. That is our factoring. And looking at this, what can cancel, what can reduce here would be the 16 and the 2. So we are left with 8x, x plus 1, all over 5x plus 3, x minus 2. Not the only way you can do this problem. You could treat it the way that I showed you in the very beginning of this little lesson. I hope this helps you. Thanks for joining me. Have a wonderful day.